Well, welcome. This is WinfoSec. We do a hopefully monthly talk. Had a couple months where I couldn't make it, but the hopefully monthly talk on information security topics. We started, this is the 8th session. We started off by doing the OWASP top 10. OWASP is the Open Web Application Security project. It's a sort of community project put on by OWASP that group to sort of help with application security. Application security is one aspect of one domain of security. Is many, right? So I do my work in data security and database security. I also develop applications though, so OWASP's part of that. There's also network security. I don't do much of that, but it's another discipline. Those are the guys who set up firewalls, kind of thing. There's also physical security, so the guys who make sure that the key cards work to the data center, all that kind of thing. So there's lots of different domains of application security of information security. OWASP deals with web applications. So application security, that is security when you're developing your applications. Primarily focused around web apps. Okay, so this is session number 8. But before we get to that, let's talk about this. Let's move this out of the way if we can. So I don't know if you guys heard about this, but we're going through Windsor is having a high-profile cybersecurity incident right now at the hospital. You guys heard about this? Yeah, okay. I guess they call it the Code Gray, which is like a degradation in health services within the region. And so it's kind of interesting that what they did was they brought the entire systems down after effectively being ransomed by a cybersecurity actor, a cyber threat, Dykeson, who said that they would expose sensitive information if a ransom was not paid. So what the effect has been is they effectively shut down their entire network and are rebuilding it. Could take a long time to do that. There's a lot of systems within a hospital. They're slowly bringing it back up low. Like they used to have to send radiation patients ready for radiation treatments to Kingsville. Oh no, not Kingsville, Kingston. So on the other side of Toronto, for their treatments because of the cyber attack. They couldn't bring those systems back up. But now that's coming back online. Things are coming back online slowly. The incident does not seem to be as bad as previously as could have been. Right? You can take a look at like their update number 7 here to see, the effects on Windsor Regional. Right? So limited portion of a shared drive. It's kind of interesting though because their entire network's down. So if something's limited, why is the entire network down? Which let's take a look at this. So OWASP is web application security. It looks like the attack on the hospital is more like a privileged account takeover situation. So the reporting isn't very good, but from what has been reported, it seems like maybe an administrator workstation was taken over, which has access to a wide variety of systems within the hospital. and that has a large amount of access. If Dixon is to be believed, they shared passwords between multiple systems that administered a workstation, and so they used the same passwords multiple places, and so they were able to get more access that way. So, but if we take a look at OWASP, it's a number of broken access control. Like that topic is mostly around web application broken access control, but this is an access control topic that's sort of somewhat related, but not too much. Cryptographic failures, no, this isn't really that. Dixon has been logging a whole bunch of network packets, and the cryptography is poor within Windsor Regional Hospital, and so they're able to decrypt it in some way. It's not really that. It's not really an injection attack. Number 4, though, insecure design. Right. So one thing that strikes me about this particular attack is that there's one service provider, Transform SSO, which does the IT services for all of Windsor Essex plus Chatham Kent plus Sarnia. So the hospital in Sarnia is down, Blue Water Health. The hospitals in Leamington is down. Erie Shores, both Windsor Regional Hospitals are down, and the Chatham Kent Health Alliance is down, as well as Hotel de Grace. So that's 5 hospitals down because of one attack. So there's 2 ways you can mitigate information security risk. One is you can prevent the bad thing from happening. It's hard from the reporting to know if Transform was doing everything they could to prevent the attack from occurring. We don't know that, really. I don't think we'll ever know that. Companies that tend to go through this clam up. They may be, in order to general report and that kind of thing, that maybe shed some light, but it's hard to know. But do you guys know the second way you can reduce risk? Risk is 2 factors. One is the probability of occurrence, and the other one is the cost of the occurrence, right? So those are the 2 things you have to take into effect whenever you're doing risk management. So the cost of this occurrence, which appears to be maybe 1 file server getting compromised, is you shut down the IT for 5 hospitals. Doesn't really seem proportional. It kind of seems like they got attacked. They have no idea what the extent of the attack was, kind of in the dark. Because they have no idea, no good information, they have to rebuild their network. Because their network is tied to 5 hospitals rather than being segregated, they have to they can't provide good services for health services across 5 different hospitals. There's a real question in my mind why 5 hospitals are so tightly linked in one network. It's a design decision. The decision's probably done for convenience and cost. It's not done for security, right? So I'm hoping that one of the things we'll see out of this attack is maybe people stepping back in the community and thinking, okay, so if a lot of this is inevitable, we keep seeing cybersecurity incidents in the news. If it does happen, what things are in place where you can reduce the costs? Did they have to have all the information that they were logging? And do they have to have 5 hospitals all tied together? It's a real question. Anyway, so that's my diatribe on hospital. Does anyone else have anything they want to say about the hospital?
Do we know if those hospitals have incidents response team so that it was just security?
Good question. Yeah. So we don't. and that's another way. So, reducing the cost of a incident. That's one of those things you can invest in, right? So incident response, and planning, like incident planning. So if something does occur, what do we do? So you're not making it up on the fly, kind of panicking. So no, we don't know, but that's another thing. The other thing, there's lots of questions like, what about insurance, right? Apparently Dyson requested $4.5 million in their ransom. Was there any kind of effort to get that reduced? Were they covered by cybersecurity insurance? Did the cybersecurity insurance cover ransoms? Some do, some don't. Was paying the ransom ever a consideration? Not. There's a moral sort of point of view around paying ransoms, in that if you do, then are you just perpetuating more ransoms in the future from either your organization or others? So maybe you don't pay the ransom for moral reasons, but was that part of the calculation? Are they doing it for that reason, or is it just that they weren't covered? They just didn't have the money. In which case, is Transform properly insured? All kinds of questions. Yeah, go ahead.
So I just noticed from an episode of Mr. Robot that one of the big issues with a lot of hospitals is that they use really old systems, like especially really old operating systems for their IT systems. Was that an issue with this incident?
Yeah, we don't know. Okay, and that's on the one plus side of the coin, which is to reduce the likelihood of attack. Are you using are your information systems up to date? Now, I don't really. In that case, are they in support? I guess are they getting security updates? Having old systems is actually very common. So, like a lot of banks will still run IBM mainframes, right? System Z to do most of the batch processing, and so having an old system is not really a security risk unless the old system is not being patched for security problems. So that's a good question, right? Hospitals often have very old infrastructure. You're absolutely right. There's most of them run on very old, there's a object data store called Epic. That the EMR works on, that kind of thing. I'm sure, but yeah, we don't know. We don't really know.
Have they tied it to a group yet?
Yeah, it stakes it. That's EAIXIN. The best reporting is probably this one on databreaches.net. So there's a few related articles to it, but you can go search their website. This is sort of like a semi-famous blogger on cybersecurity incidents, a lot in healthcare, but also in government. And so news aggregator. Plus, he does some independent reporting himself as well. So that's good. He's also very active on the InfoSec.exchange if you're in Mastodon. If you're in Mastodon, okay. Any other questions? All right. And guys on Zoom, feel free to post questions in the chat, and we'll take them up too. Okay. So let's go on to the actual primary topic of tonight, which is software and data integrity failures. So, software and data integrity failures, like I mentioned, is number 8. So we worked our way all the way down the list to number 8. We might do next time security logging and monitoring failures and server-side request forgeries as one topic. Just to get this done before the end of the year, maybe. Let's close out the new year, finishing OWASP. But yeah, so number 8, software data integrity failures. So what is that? So Basically, it's the idea that you only run code that you trust or is vetted in some way. So we'll talk a little bit about what that means. So if you're an application developer, remember OWASP is primarily focused around application developers. Is the code that you import into your project, you probably import a lot of third-party libraries. Is it, coming from a trusted or vetted source? And what is the plan for you to make sure that you're not fooled into getting maybe the wrong package or into downloading a tainted package? What is the plan for you to do that, to prevent that from occurring? And then another one, which is also in this topic, but like I mentioned in the other OWASP sessions, is that a lot of stuff, these categories are getting broader as they try and encompass more and more threats into the OWASP top 10. And so deserializing of unencrypted or unsigned data as all code. If you're passing that within your application, maybe some of it goes to the user and then or client of some kind, like the client being the browser, and then passed back. Are you ensuring that data hasn't been tampered with in some way? So what's the kind of signing or verification you do in that? So let's talk about Chatsploit. So for those who are new, Chatsploit is the per application that we hack. So I built a chat application, like sort of like Facebook Messenger or Google Talk or whatever. You type in messages and send them to each other. And Chatsploit is special in that it has very, very poor practices in it all over the place. So in the injection talk, there's SQL injection vulnerabilities all inside Chatsploit. So in our injection talk, we actively exploited those and saw the results. And then in the second half of the talk, normally we patch it. It'll be a little bit different for this one because there's no real way. It's a little bit harder to exploit, a little bit no real way to mitigate completely. But anyway, that's what Chatsploit is. Don't use Chatsploit. John Haldeman, Chatsploit 2. It's got a whole bunch of poor practices. So don't take it as code you should reuse. Please don't. It's purposely bad. Okay, so Chatsploit 2. One of the things that Chatsploit 2 imports, these are all the dependencies. So it's very hard to do encryption. So I use a library called Iron. And then there's another, it's kind of a pain to do authentication. So I use popular authentication library in Node.js called Passport. And then it's hard to write your own database. So I use SQLite. And SQLite 3. These are the clients to the SQLite database that Chatsploit has. It's a React app and so on. It also uses this library called Cookie. So this wasn't working earlier today. So let's see if it works today. Works now. It does. Okay. So good. If you look at so cookies in package.json. So that's the application. And then inside my auth cookies and inside auth, so I use serialize and parse inside the cookie package in order to serialize and parse cookies. So cookies, you probably all know, they're little pieces of data that the browser and that the server asks the browser to set, and then the browser will echo that cookie over and over again. It's primarily used to one of the things it's used for is authentication. So when you authenticate to Chatsploit, you get this cookie that says you've logged in, and it has your JavaScript Web Token that identifies you, so that you can use the application. So serializing and parsing cookies is kind of a little bit of a pain, and so this library lets you serialize and parse cookies. Pretty simple library. Question, it's a cookie. But this is code, right? This is code. You can see this is actually running in lib. The lib gets imported by a variety of other things. My API for logout. It's also in, so like my logout API. I think also inside my login. And so we have this cookie library. It's actually in sensitive code related to authentication. And so it's actually doing things that are security sensitive. But let's go look for cookie. So npm cookie. So this is the cookie package in npm, right? And so it's good. It tells you which repository it's in. So, okay, so there you go. Let's go here. All right. This is the cookie. It's in JS HTTP. So low-level JavaScript HTTP modules. Okay, that's cool. And then you look at, there's some contributors here. These people that help you that help with cookies and help maintain cookie. Simple library. And then there's Doug Wilson, I guess. Doug Wilson seems to be heavily involved in the repo. But like, who's Doug Wilson? It's Doug Wilson. So yeah, it's this guy, I guess. All right. Digital glyph artisan. Anyway, so he lives in Indianapolis, and then he does independent software work for like independent software consulting. So he just does a lot of cookie stuff as well as other things. So the question is, okay, so this is just a community maintained project. What if Doug Wilson gets compromised? Like his account on GitHub, or maybe the ownership of this repo goes into question. Maybe Doug Wilson dies. Like, where does the control of the repo go? What if Doug Wilson gets in trouble with organized crime, and then they bribe him to change cookie to go and steal authentication tokens from all the dependent applications that use cookie? These are open source projects, and so there's a good question about whether you should use it. I mean, a relatively popular one, 1.2K stars, 148 forks. People have used it. So that's the kind of thing you would worry about in Chatsploit. And the real question is, okay, so it's dealing with sensitive code. Do I really need a cookie parser? Maybe I don't need a cookie parser. Maybe there's a library on a bigger project, right? So like maybe Node.js has in part of its standard library cookie parsers. So maybe I should go and look at that. So that's the kind of questions you should ask yourself around dependencies that you add to your projects. That this particular OWASP thing tries to have you ask, right? So good. All right. So that's it. Really, for Chatsploit is ask those questions. Look at the things that you import. make sure that they're reputable in some way. Think hard if you really need to include them. How many eyes on the repo so that if it does get compromised in some way, you might get notified before you happen to include it in your application. All right. The other part about this is, okay, so if you have an application and it downloads updates automatically, it can also be a vector for attack. So what gets compromised is the update site. So the SolarWinds Orion incident from 2021 was where SolarWinds Orion, does anyone know what SolarWinds Orion is? Oh, whoops. So SolarWinds is like a infrastructure, software infrastructure company. You'll see they do like a bunch of stuff for, I don't know, what are they trying to sell on their website? IT service management, database performance monitoring, network management, systems management, application management, IT security, right? So buy our software to help you understand the performance metrics for your database so that you can tune it. Your DBAs can tune it better, for example. SolarWinds Orion is supposed to allow you, device manager. So let's go key features. Yeah. So like network monitoring and that kind of thing for, here. So NetFlow traffic analyzer. So NetFlow is like a protocol for understanding the flow of traffic within the network. IP address manager. So if you have duplicate IPs all of a sudden on the network, you can identify the duplicate IPs and resolve that. Voice over IP, network quality manager there. Storage resource monitor, so you can understand when your disk space is getting full. Web performance, log analyzer, a whole bunch of stuff on Orion, right? So, and pretty like sensitive IT infrastructure things. Makes it a pretty good target. So what happened was Russia, so it was the state actor in this case, broke into the update server for SolarWinds and put in a bad DLL. So DLL's the libraries that your Windows applications will use. So put in a tainted DLL onto that update server, and then that DLL got distributed to customer sites. So by just updating SolarWinds, Microsoft has a pretty good analysis of SolarWinds Orion if you want more detail about how they did it and how it worked. This is their diagram, but you can just imagine. So if you can taint a library, put it on the server, then that's a backdoor in the network infrastructure layer of a whole bunch of people that use SolarWinds Orion. And it was a lot of companies. Now you had to do two things. One, you needed to get the update from automatically. So SolarWinds phoned home and downloaded it. A lot of network infrastructure devices don't connect to the internet directly, and so the administrators download those updates manually. So you'd have to have it download automatically and get it applied. It's actually probably a pretty good practice not to have your network infrastructure talk to the internet directly. That's common. Again, that's like a network security topic that we, maybe we'll talk about at some point, firewalls and that kind of thing. So anyway, this is attack timeline. So it took a while, right? So in 2019, in September, they injected the code. And then they went through like a test cycle, and the initial compromise on those in September of 2019. Then more stuff happened in February and March of 2020, and then eventually they released the actual compromise in January 2020. So Crypto Security has a pretty good write up on that as well. So good. All right. So that is SolarWinds Orion. Any questions about SolarWinds Orion? So mitigations. So let's use Orion as a lens on these mitigations. So these are the mitigations listed on the OWASP website. So all of this, by the way, if you go to the OWASP website and you look at this particular thing, you can get more detailed descriptions. They also talk a little bit about SolarWinds there, and then what I find really useful about these are the CWEs, the common weaknesses and exposure. So if you have like a specific question about what they say up here, and you need so what was an example of something? CWEs can provide that information, so more description, and often they have examples, but then they have an example on this. Let's find one where they have an example. Deserialization on untrusted data. Yeah, so they'll even have code examples. Mostly Java, some Python. So but you can see what they mean by deserialization of untrusted data and then running it. It's kind of a similar thing, except the data comes from the user in this case. All right. So let's talk about software digital signatures. So software digital signatures is, so you get an update and it's signed in some way by the original vendor. So in SolarWinds Orion, it came from SolarWinds because it's signed by SolarWinds. Would that have helped with the SolarWinds Orion thing? Probably not, because SolarWinds their CI/CD pipeline actually got compromised. The DLL that those bad actors added would have been signed by SolarWinds, and so it doesn't really have to help with there. But it does help if, for instance, the update site gets compromised. Let's say with a DNS on a DNS attack. So let's say the update site is chatsploitupdates.com, right? And then because I'm a bad administrator, I let chatsploitupdates.com the DNS name lapse. Some bad actor takes over the DNS name and tries to distribute a bad chatsploit update through that DNS name, but he doesn't know how to sign my packages. So my existing software won't update itself because the signature is incorrect from the bad actor. He would have to have my key in addition to my DNS name. And so that would have helped with that attack vector. It wouldn't have helped with the SolarWinds Orion attack vector because they were inside the SolarWinds server. Okay. So review process for new packages, not really SolarWinds related. This is more the cookies thing. So not only should you include packages, but have someone else in your organization look at your code and ask you questions about whether the package is necessary and if it's legitimate. Trusted repositories and package staging. So what this is you have an update, but you bring it into an intermediary area first. So you say, I don't update directly from the source. I download my updates to this intermediate area, do scanning on them, and then when I'm happy, I will pull from that intermediate area. So there's some indications that SolarWinds Orion would have helped with SolarWinds Orion because the Windows Defender scanning was pretty good heuristics on it. but the more importantly, you can get those updates sooner. Like you keep that server updated, and you don't apply right away. It goes into the staging environment for scanning first. You have a little bit of a delay before you apply your packages, and then hopefully you can hear if the package has been compromised before you bring it into your application. So that's what like package staging is. And then a secure CI/CD pipeline is okay. So SolarWinds prevents the problem from occurring in the first place by not allowing their update server to get compromised. That's kind of simple. And then you just use all the cybersecurity principles to prevent the CI/CD, the update server from getting compromised to begin with. Not very helpful, but they just say secure it. Another thing they do here is, I didn't talk about it much, but inside the OWASP website, they talk about make sure you're updated. Okay. They do it. Okay, they didn't. Okay. So keeping your packages updated for known CVEs, so known vulnerabilities, is this part, is A06. So it's slightly different from A08. This is, there's a known vulnerability and you haven't updated your packages in time. This is, your package was a package that was supposed to be good was compromised in some way, or you used a package that was just bad to begin with. So slightly different attack vectors. Okay. Good. And that is it for software and data integrity failures. So just make sure that any application updates you get, well, try and have some process in place to prevent them from, to help vet them from being malicious, and then also use legitimate packages in the first place. Any questions?
Yeah, just wondering if I can ask questions.
Yeah, absolutely.
Can you go back to the slide with the mitigation strategies?
Yeah.
The first one, they show signatures. I still don't understand why you said that couldn't have prevented the SolarWinds.
Okay, yeah, because if you look at their, so over here, they compromise it. So inside the CI/CD, so in the build process, they compromise it enough to inject their own libraries into it. And so how software signing often happens is you get your software, you get the libraries, they all compile together, and then the package gets signed to make sure that it isn't tampered with.
Right. That's like code signing.
That's right. It's like code signing. Yeah. Okay. Yeah. What happened was they got the package, the library was tainted, and then they would have signed the tainted package.
Oh, so it's already embedded in the whole thing. So
it happened earlier. So it's still very good. Software digital signatures would have helped with some vectors, but not this one. This one was like secure CI/CD pipeline. That's how SolarWinds was supposed to protect the customers. Package staging, so not applying the packages right away, and also doing some due diligence before you apply them.
Is it what is it called, sandboxing?
Yes, so very yeah, exactly right. And so that's what customers would do to protect themselves from SolarWinds packages being tainted. So yeah, that's SolarWinds does this. The customers do this. Any other questions? Other instances in web app design where the failure of initial security almost creates a Trojan horse. Other instances. It's a good question. Where the CI/CD compromise is, the CI/CD chain is compromised. Okay, so let's see another way. Examples of, like, it's big software supply chain attacks. is sort of it's like the big this is the like software supply chain is sort of like the so here's some case studies. So SolarWinds, there you go. There's one. SolarWinds Orion, we just talked about. I guess maybe the Equifax one. That was a big one. But yeah, it's sort of, it was a hot topic at least last year, or I guess earlier this year. So yeah, there are other examples, but I didn't have any off the top of my head, and I was just Googling for you, Dylan. But if you look for supply chain attacks, there's a whole bunch of companies trying to sell you security software. That will give you more examples. Yeah, so give that a shot. This in this case, it's Cisco. I'm sure Cisco has something they want to sell you. I wonder what. Yeah. Okay. Good. Anything? Any other questions?
Can I have another one? If
Sure.
there's no.
Yeah.
Sorry, I'm pretty new to application development. CI/CD is.
Oh yes. Okay. Yeah.
And then, but now I heard about another framework. Is this similar, like called Agile?
Yeah.
Is it something similar or different, and how does that impact like security?
Not really. Okay, so CI/CD is continuous integration and continuous deployment. So this is when you change the software, you publish it, and it automatically gets built and tested through automated testing to make sure it hasn't broken anything.
Okay.
So, and then from a security perspective, it will also get scanned to make sure you haven't included any new libraries that have no vulnerabilities.
Okay.
So we use white source for that at work. There's also a bunch of others. In our CI/CD pipeline, you also have like internationalization. So if we put in any text in the software, it has to get translated, and so it will automatically go to like the Swedish translator and the German translator, and so they'll translate those strings and then put them back into the product. That's also part of CI/CD, and so that's just So that's what CI/CD is, like build process, and then the security functions of the build process.
Okay.
And then the other thing, Agile is more like a methodology for building software and arranging teams.
Okay.
So the big thing there is continuous iterations, short iterations of software that you can deliver to customers quickly, so you can get feedback, so that you can make modifications early in the software development process. So that's more the Agile thing. Now, Agile gets used a lot. So like Agile cryptography.
I guess what I'm trying to thinking about is that if you're trying to shorten the development process, then wouldn't it sort of have less time to sort of test, the security implications and everything?
Yeah.
And just makes things a little bit more insecure.
So yes, it is. There is a tension there, in that and continuous delivery and that kind of thing. So you want to, especially with a lot of SaaS products and that kind of thing, you want to be able to make changes to code and then it go out to customers quickly.
Quicker, yeah.
But there's a tension there in that if it's going out to customers quickly, are you putting in security problems into the application? I'd be most worried about the top half of the OWASP, where it's like broken access controls, where you make a modification to the application code, you do it in a big rush, or you do it fast without thinking about it, and then all of a sudden, the one user can see the other user's data, kind of thing, right? Or you have an injection vulnerability. So you do it quickly, but the application has SQL injection problems or cross-site scripting problems, and they weren't properly vetted. Traditionally, like so for broken access control and injection, the traditional way to detect those is there's some automated tooling that'll do it, but a lot of the time it's red teams, so pen testers will go and see if they can compromise the application. And if you're doing agile, or your pen testers also testing the code that's getting deployed often. There's a real tension there because pen testers are busy. And so maybe the pen testers only do it quarterly or something like that.
Yeah.
I know at work we probably could get them involved more often. Yeah, but it's but yeah, there's definitely a tension there. Yeah, good question. That's the thing. There is generally a security productivity tension. So if we talked a little bit about the hospital cyber attack, and I went on like you shouldn't have a situation where if one hospital is compromised, in this case it was Blue Water was compromised first, that it brought down 4 other hospitals at the same time. But there's probably efficiency gains by having one consolidated network for all 5 hospitals. Probably a lot easier to work on the network. It's probably a lot easier to share information between hospitals. The IT department doesn't have to have so much process around it, so you don't have as many people in the IT department. But that's a decision that was made. So you can have those things. It's just real trade-offs. So you just have to make those trade-offs apparent, so that you're doing those things for the right reasons. So that you don't make for something. Maybe there's other things in it that weren't much benefit, but they just did it because that's the way they've always done it. But yeah, that's what that's.
So I have a kind of question related to one of the mitigations that's kind of related to what you're mentioning now. So you were mentioning that for like if you wanted to use, let's say, software digital signatures, that only works if like the attack was, I think that's called the DNS spoofing.
Well, yeah. So that's one vector for that attack. But basically any attack where you fool the customer in downloading a bad update.
Right.
Yes.
Right. And then you were mentioning that for like something about a intermediate
like a staging area.
Yeah, staging area. So you're saying that when they're trying to go for the update, connecting to the updates, or there's an intermediate like that's where I kind of got lost.
Yeah.
Explain that.
Yeah. So we do this at work. We don't get any of our packages from the internet. We stage all our packages in a lot, and we use Artifactory, which is by JFrog. It's like a local repository that we get we do a bunch of container work. We get our containers from it, and we get our packages from it too. That staging allows the organization to prevent stuff that they know is bad from going to the product. So I can't really include a package because it has to go through Artifactory first, and then that prevents them so that they know. So in Orion, it really only would have helped in preventing the damage from getting widespread, right? So I'm getting it from that repository, not from Orion directly, which means there's a delay, and also we know exactly who the consumers of that package are,
right? So
that we're able to respond if one of them did actually download it. So it's just controlled access to the open source. Or
I see. Kind of controls it from being the intermediate between the main update server and the recipient.
Yes.
Okay.
And I tell you, it's a pain. Again, it's one of those things.
It just seems like it adds so much complexity to it. Yeah.
Yeah, exactly. And so it is a pain, and so but we do it in order to get some of the benefits of that. There's other benefits in that you don't want to include so for us is like legal benefits. So open source software that we can't that we're not allowed to use in a legal sense. So GPL, new public license libraries, are like this, where if you include one of those libraries, it makes the rest of your code open source. We call that a viral license. But we're a closed source company, so we don't want the rest of the code to be open source. So we can't use GPL. We can use MIT. We can use Apache. And so the code scan, the intermediary download will then prevent us from using GPL things as well. So there's other benefits other than security. There's like legal benefits there.
Okay. Yeah. And so you mentioned the best bet is just to secure the CI/CD pipeline.
So yeah, or for the Orion problem, yes. Ideally, SolarWinds wouldn't have gotten compromised in the first place. Right. We wouldn't be talking about that. So
that's where I kind of wanted to understand. How did they initially get? Like, what was the vulnerability that they could get in to place the backdoor into the updates?
Yeah, good question.
I don't know if it's known.
Yeah, no, and I didn't see it in anything I read. That doesn't mean it's not known. Had to do a little bit more research. Often it's not known
because it's 2021, which is before they caught. Like, I know they were catching Log4j and a lot of these big vulnerabilities that were. Now, I think they found in 2022.
Log4Shell, yeah.
Log4Shell.
Yeah. So we talked about Log4Shell in the previous one. But yeah, there's lots of but that's the problem, there's lots of vectors. Part of the reason they don't tell anyone is because it's often embarrassing. Right. So I don't think we'll ever know directly why the hospital got compromised. Right. Because it's an embarrassment, but also because it's actually not that easy to find out.
I think they did mention something in one of the newspaper articles saying is, the VPN network got compromised is because some part of it didn't enable the MFA, the multi-factor authentication. So it could attack would just brute force it and figure out a password.
Or credential stuffing, right?
Yeah.
Yeah, that's absolutely right. So yeah. So that would be stuffing. Yeah, credential stuffing. So credential stuffing is so brute forcing a password is quite hard because you put in some password complexity rules and it sort of goes away. What credential stuffing is there's been a whole bunch of breaches, right, in the past. And so what you do is you look at those old breaches to find credentials that maybe an administrator used on a different site. And then so then they try to log into the VPN with that same credential. That's credential stuff. So you reusing a credential that's from a list of previously compromised credentials. That's why you should never use the same password in multiple websites.
Guilty of charge. I always use the same password.
No, don't do it. Get involved.
Remember.
Get involved. Look, I got my vault here.
Get a password manager.
Yeah, you gotta use the password.
Yeah, you gotta do that.
It's lazy, I know.
Yeah.
It's the best practice. But it's just human. Okay?
Yes, that's fair. And it shouldn't be protected by MFA. So it's definitely so you can't rely on MFA, but it's a fantastic mitigation mechanism. So MFA was I think we talked about it in broken access controls, but it might have also been insecure design. No, MFA was last time. Everything's a blur. So MFA was 07. So we talked a little about MFA, and so all of these talks are actually on the HackForge YouTube. If you want to see last month's talk, we talk about MFA, and then we actually changed the application to add MFA. So we added MFA to Chatsworth.
I'll check it out.
Yeah. We use TOTP. TFTP is nice because it doesn't cost any messaging email. Okay, all right. So that's all I have for today. It's 8:01. Thanks everyone for joining. I really appreciate it. Thanks for posting that thing, Sherry.